All right, so my name is Christopher Laco. If you're a coworker or a friend after this, call me Claco. That works. It seems to stick. I'm a DevOps engineer at Rackspace, and I think that's really Latin for break servers. It's kind of weird trying to cram a long presentation into 10 minutes. So we don't have time for really Ruby cat photos, dog pictures, or even goats. I'm sorry, but this is a sacrifice I've made for you. So let's talk a little bit about sort of the frictions of our development environments and our producer and consumer of things, right? We have things like libraries where I create a gem and it gains some traction, and I create a framework, and then I create a product, and then maybe I go full distro or an image or an appliance or something like that. Each phase of this sort of has its own risk and rewards that you have to weigh. We talk a lot about this week about continuous improvement, continuous deployment and delivery. These things mean different things at different phases of this cycle. If you're doing a Ruby gem, continuous deployment is awesome. Like, I'll put out 10 versions a day. This is great. Framework, sure, a couple a day, maybe 10 a week. A product or a distro, I would shudder to imagine if, no offense, but if Chef released a new client or server version 3 times a day, this would make me nervous, or an operating system many times a day. So there are certain situations where the trade-off between continuous improvement and delivery fights the consumer of the product. Same way with release early, release often. Again, it would be horrible to have things break out from under you every day because there's a new update. And part of this comes back to risk management. If you're the consumer, if you're the producer of these things, you sort of have a contract with the user not to introduce any risk on their part if they want to upgrade. They have their trust in you. And what this really means is stable long-term releases. Like, we all want it, but we have to make some choices along the way between stability and quick improvements, quick fixes, et cetera, et cetera. And the more complex the product, of course, the wider the gap in those things. So let's talk a little bit about risk acceptance. At least for us in the RCB Ops and the Chef Cookbooks for OpenStack, we sort of treat risk a little differently depending on the branch you're on. So if we're in master, this is a game on anything. Like, if it passes gating, it goes in. It could be new features, new improvements, next version of Icehouse now that has dropped, bug fixes, etc. As we move down to stable branches, Havana, for example, we want to do some improvements, but we don't want to get too risky for our customers. We don't want to introduce new features that may break them. And of course, even older releases like Grizzly, it's just fixes only. Like, it would be crazy to add new features to a branch in a .2, a .3, or even a .8. As the farther down the chain we go, the more risk any change introduces. So a little bit about our cookbooks. Currently our RCB Ops cookbooks for OpenStack is about 25 cookbooks. We had 3 releases in 2014, 14 releases in 2013, and we always maintain at least 2 stable branches at any given time. It used to be Folsom and Grizzly, now it's Grizzly and Havana. Soon that will be Havana and Icehouse. Now let's contrast that to our dependencies. Right, there are 20 cookbook dependencies, give or take, depending on our branch. Things like, of course, Apache, RabbitMQ, MySQL, apt, yum, NTP, et cetera, et cetera. Across all of these dependencies, they've had 39 releases in 2014, 135 releases in 2013, and for the most part, all of these only maintain a single stable branch, which is usually master. So to plot that out, hopefully it's easy, somewhat readable back there. But every dot on this chart represents a tagged release of our dependencies across the last year and 4 months. And what happens is, for large, complex products, each one of these tagged releases of a dependency is a risk. Picking any one version between a .1 and a .2 and a .3 release is introducing more risk. Again, these are tagged releases, so there could be hundreds of commits between each tagged release. Each of those commits is a risk. Now, if we compare that to our Folsom, Grizzly, and Havana, On the lines there, you'll see that because the product is complex, we have a very different release cadence than our dependencies. And this becomes friction between the things we use and the people that consume our product. And we have to weigh a fix versus how much risk does that introduce to the customer. Some of these risk generators, as I call them, are really sometimes mundane things. Like how many people have been bitten by a cookbook that changes the service from a reload to a restart? Or a notifies from an immediately to a delayed, or delayed to immediately when you drop a database config file. These are things that, if you're wrappering that cookbook, can sort of bite you without any warning until you track it down. Could be things like pending cookbook fixes, major version changes on some of these releases, like the Yum split, for example, from the 2 series to the 3. Just intermediate changes, any old commit and fix along the way between those releases. And I started this because another risk is the movement between a monolithic cookbook of all your recipes moving to a separate cookbook for the topical recipes. But that's a risk, right? Because it's easier to maintain one monolithic cookbook than it is 25 separate ones. But for everybody, that's not the right answer. So to sort of put this into a real world use case here, if we look at the green on the left, maybe that's the version that we've put in our Berkshelf. And it's the version for 4.2.0, it's the version for 4.2.1, and somebody decides, oh, we've got a bug, we need to fix it. Maybe this is the Yum apt cache change, or let's say the NTP security fix for monlist. Well, we have to weigh, I need that fix for a customer, but do I really want to drag along the 4 other releases? Is that risk acceptable to us? Even with all the coverage and the testing and the gating, things happen. And our customers are sort of depending on us to make sure they don't happen for them. So Berkshelf and Bundler. I sort of lump these two together because I think they have the same feature set and they fix the same problems and they introduce sort of the same issues as well, where they're good for reproducing dependencies, but they're not really great for managing granularity of your dependencies. So there's a few things we can do about that. And I liken this to a distro. If you want to ship a package, let's say it's the OpenSSL fixes, right? All the distros have a different version that they ship, and not all of them upgrade to the latest version. They take the version that they ship and they just apply that one security fix because that's less risky than upgrading their computer base to, let's say the latest and greatest. Which really means everybody's got their own forks. And I think this is one of the things that GitHub is a blessing and a curse. It allowed everybody to have a fork of something. Everybody can maintain their own copy, but now finding the single source of truth is also more difficult. But it has its place, right? The place is stability for your customer, knowing exactly what's going to ship and go out the door. And again, to reduce these generators of risk, because now you have a code base that's locked to exactly what you need. So there's a couple of things that we do, both at work and personally, that have made our lives a little bit less risky when it comes to deploying this product. One of those is Berkshelf forkinating. Yes, sounds wrong every time. Essentially, we'll take a cookbook, an upstream resource, let's say it's NTP or apt or Yum. We'll fork it, add upstream as a remote, cherry pick in maybe a cook fix that's still pending, could be pending maybe longer than our release cadence, and we'll point our Berkshelf to that specific version. So instead of depending on upstream cookbooks directly, fork those all into your own repository and now sort of lock those down for stability. And then, of course, sleep at night because you're not going to get any unexpected fixes. Just to put that in a little code, again, we'll clone, hub clone, create a new integration branch from a version. So let's say 1.5 is our base. We'll check it out, and we'll cherry pick a specific commit, and then we'll point our cookbook to that specific version, our Berkshelf. Another one is submodulation. I just made up words, sorry. It's the same process, but we'll use submodules in sort of a monolithic repo to point to all these separate cookbooks. So we'll fork it, add an upstream remote, create an integration branch from release, cherry pick, again, the local upstream or the PRs that we find relevant, get submodule to that, and again, sleep at night because that's not going to change. And also wrap gating around that. And code is pretty much like the other one. Clone it, branch from 1.5, add our cherry pick, and point the submodule at that so that we're locked to a specific version and no more dependency craziness. This is one that I actually wish we had. There's a lot of talk about Docker right now. And I think it appeals to everybody because it's very building blockish, right? I specify a base image, I add some scripts, I expose some ports, I install some software, and at the end I have a product that I can just run. And it's the same everywhere without any of this system packages nonsense or all the kind of stuff that we have to deal with in a risky manner. So what I wish we had, and you can do this with a shell script, right? But what I wish we had was something like this for Berkshelf, where I could say, here's my cookbook. I want you to use as a base version 1.5. I want you to apply this change set, or in this case, I want you to patch it with this patch file, just like you would upload a file to Docker. Let's build it and then package it. That's really just some ideas that I had. I wanted to just really talk about the risk management and Berks file. So thank you.